Hello, welcome back to the channel. So let's continue our discussion on numerical integration and solve one more question on finding the largest possible error if we'll calculate this integral using the midpoint rule approximation. So generally in these type of questions, there is a single pattern that you usually follow in order to calculate these error approximations or the largest possible errors in this question. And the basic process to calculate these largest possible errors is broken down into two steps. The first process is to basically calculate the value of capital M or capital L as given in the formula. And then based on those values, the second step is to use those values of M and L and plug them in this largest possible error bound equation to calculate the final answer for these type of questions. And also for these type of questions, you are always given these formulas in order to calculate the final answer to your solutions. So don't worry about remembering these formulas. The only requirement in order to solve these type of questions is to get the good idea about how these questions are solved and how the values of M and L are calculated in order to calculate the final error bound in these type of questions. So we have already covered these concepts in detail in the previous videos, and I would highly suggest you to first watch my previous videos in order to get the full context of this video over here, or in order to get the full explanation about this question over here. So first of all, since we are using the midpoint rule approximation, the total error using the midpoint rule approximation is given by this formula, where if you want to calculate the value of capital M, you will solve this inequality over here in order to calculate the value of capital M in this case, where in other terms, this capital M value is basically the upper bound on the absolute value of the double derivative of f of x, where f of x is basically the function for which you're calculating the integral for. So in this case, since we are approximating this integral over here using the midpoint rule, our fx is basically, in this question, our fx is 2x to the power 4. And now in order to calculate the value of capital M, we'll have to first find the double derivative of f of x, which in this case would be, we'll first calculate the first derivative. So the first derivative would be 8x cubed. Calculating the second derivative, it would be simply 24x square, right? And now since we have a double derivative of f of x, we will have to calculate, in order to calculate the value of capital M, we'll have to calculate the maximum value of this expression over here within the intervals given. So since x varies from a to b, in our case, a is -2, b is 1. So our x in this case, in this question, is varying from -2 to 1 in this case, right? And based on the values of x in this interval, we have to calculate the maximum value of this expression over here. And clearly, you can see that if you plug in x equals -2 in this equation, you'll get the maximum value of this expression over here, right? So if x is equal to -2, your f double dash x is equal to 24 times -2 whole square, which is basically 24 times 4. And if you'll calculate that, this will be basically 96 in this case, right? So now you know that the maximum value of the absolute value of the double derivative of f of x is 96 in this case, right? So now we got the value of the upper bound on the absolute value of double derivative of x, which is basically m in this case. So m is equal to 96, and now since you got your value of m, it's very easy to calculate the largest possible error, right? Because now you have the value of m, you have your values of b and a, and you also know that you're approximating using the midpoint rule with 60 subintervals. So now you know that the value of n is 60 in this case. So if we use this formula in order to calculate the largest possible error, our largest possible error in this case, so the largest possible error in this case is given by the formula m times b minus a to the power 3 upon 24n square, right? So this is the formula, and we know that the value of m is 96. So the largest error in this case would be 96 times b is 1 in this case, a is -2, as you can see in the interval as well, in the definite integral. So b is 1, a is -2, and then your n is 60 in this case, right? So it would be simplified to 96 times 3 cube upon 24 times 60 square, right? So when you'll solve this expression over here, you'll basically get the answer to this question, which would also be the answer to the largest possible error between approximating this definite integral using the midpoint rule and the true value of this integral over here. So that's it for this video. Again, the main takeaway from this video is that you don't have to remember these formulas. You'll always be given these formulas in order to calculate your error bounds. But the main requirement in order to solve these questions is to know the correct approach on how you would solve your values of capital M and L, and then use these formulas or the formulas given in the question to find the largest possible errors using different approximations that we already covered in the last videos. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.